Hello viewers, hope you are doing fine. So here we are going to discuss about the Kruskal method. So in the previous video we already discussed about a greedy method. So whenever we want to find out the best solution, you just give the preference to greedy algorithm. So in that greedy algorithm, two different types of methods are there. The name of the first one is Kruskal, then the second one is Prims. So here let us see what is the usage of Kruskal method. Constructing the spanning tree is most important one in computer science and network design. So among two algorithms like Kruskal and the Prims, Kruskal is the simplest one to construct the spanning tree. So at the time of building the spanning tree, we are going to add edge one by one, depends on the smallest weight without forming any cycle. This is the constraint to construct the spanning tree. So before that, you must be clear what you mean by graph. Graph is the collections of node. It is also called as the vertex. So each vertex is connected with the help of edge. Then we are giving the weight between the edge. Weight may represents the distance or time taken to reach from the one vertex to another vertex, like that. So these three key points are most important one to construct the graph. The first one is vertex, which represents the node. Then the second one is edge, the relationship between two vertices. So third one is weight. It may represents the time taken from visit from one vertex to another vertex. Next one in a minimum spanning tree. So first we have to find out the or list out the weight in ascending orders with the help of any sorting algorithms. You just write the weight in the ascending order. You just first take the smallest value to construct the spanning tree. So at the time of constructing the spanning tree, you must keep one thing in your mind: the graph should not consist any cycle. So that is called as the spanning tree. So here the first one is connectivity. We are going to construct the spanning tree without any isolations. You must not left any vertex. Then the second one is optimization. We are going to find out the minimum spanning tree. Then just avoid the redundancy. So that is called as avoid the looping. So at the time of constructing the spanning tree, must you just keep the set empty, then arrange all the edges in ascending order, like depends on the weight. You just arrange the weight in smallest to largest. Then add the edge into the empty set. At the time of adding, you just check whether it creates any cyclic or not. If it touch the already visited vertex, you just neglect that. Then continue with the next smallest value. So check the connectivity means you must check all the vertex are visited once or not. So at the time of constructing the spanning tree with the help of Kruskal algorithm, the time taken for that is order of E log n. Here E represents the number of edges, n represents the number of vertex. Why it takes the order of E log n means it depends on the weight. It may the time may be differ. So here we are applying the comparison sorting algorithm to arrange the given weight in the ascending order. So it may differ, depends on the number of vertex in each graph. So that's why the total time taken to construct the spanning tree using the Kruskal algorithm is order of E log n. So practical applications where we are applying the Kruskal algorithm in real cases. The first one is communication networks. If you are going to design the data network, it is efficient one. Then the next one is transportations. Whenever we are constructing the road map, so at the time it is mainly used to find out the minimum distance between the cities. Then the last one is utility systems like electricity, water and gas. If you are going to plan the grid, you just use the Kruskal algorithm to construct the spanning tree. Hope you are clear in this video. So whenever we want to find out the optimal solution, we are going for the greedy method. So out of two algorithms, the simple most one is Kruskal. So in the next video, we will discuss about the prims. Thank you.